Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And cool kids never have the time to do stupid things, but they certainly have time for the mathematics, which we are getting to right now. Bit of algebra. Let's talk function notation, shall we? All right. I love this thing. I'm going to copy it because I want it to come back here in a second. Let's move forward. You might have seen the function machine. It's a bit childish, but effective and does a nice job of indicating the concept of function, which is central to the understanding of algebra and mathematics. The simple concept of function. Here we go. We have an input. That is going to be your domain. And it says I double the input and then subtract 1. So doubling x, subtracting 1 is represented there. That gives you your range. Okay? Now, we're not going to do machines. We're big boys and girls. We're going to have some notation. Yes? So we have the function 2x minus 1. And this is one sort of notation. I'm not a fan of it, probably because I didn't grow up with it. I'll show you the notation that I'm in favor of or more familiar with. But I need to show you this because it appears often enough in what we're doing that you need to understand what it means. So this function can be written, the function f, such that x is converted to 2x minus 1. Now that's a very nice definition. It gives you some conceptual understanding there, but I think it's a little hard to remember. So the function f such that x is converted into 2x minus 1. So if there were a 3 here, we would just replace this x with 3, and the function of 3 would be equal to 5. That's what they picked up there. Moving on, here is the notation that I'm familiar with. This is, or you say this, f of x equals 2x minus 1. This is not f multiplied by x. It's the function with respect to x, the function of x equals 2x minus 1. We also can say y equals f of x. A lot of people get all uptight about that, but f of x is another way to write y. What else do I want to say here? Oh, I know what I wanted to do. I wanted to bring this in. So this notation, this f here, let me move this to the left so we can keep it here for your notes. I'll make it a little smaller. It's very nice. The f is the generic name for the function. The f, I hope I said f. The x is the generic value for the input value, and the whole symbol constitutes the output value. Okay, altogether it's the output value. Okay, what's down here? So this f of x is read f of x and is the value of the function at any value of x. F is the function which converts into f of x. F of x is sometimes called the image of x. We really focus on the first two bullets here. Okay, so this is the graph of f of x equals 2x minus 1. So the domain would be all potential x values. There's no restrictions, so that would be all real numbers, and the range is all output values, which I think we can clearly see there are no restrictions, so that would also be all real numbers. All right, so let's just do a couple of things here. This is pretty easy. We are just going to replace x with 2, and we get 3 times 2 squared minus 4 times 2, which is 12 minus 8, which is 4. And then I'm going to use this notation. F of negative 5 is equal to 3 times negative 5 squared minus 4 times negative 5, which is going to give me 3 times 25, 75 plus 20, which is equal to 95. I breezed through it. Hopefully I didn't make a silly error. Here's some other ones, and folks get all confused about this when we replace variables or a variable with another number. We have f of x equals negative 4 minus 3x minus x squared. So if I want to find f of negative x, this is the input value. It's the placeholder for what I'm going to replace x with. Oh, but it's x again. It's just a negative. It doesn't matter. Whatever is here, I replace every single x in the function. So this becomes 4 minus 3, and instead of x, I am replacing it with negative x. Minus from right here, and then I'm going to have negative x squared. Parentheses, pretty darn important there. So this becomes 4 plus 3x minus negative x squared is positive x squared, but we still have the minus out there. So there we go. F of x plus 2. Again, but there's an x here and that says x equals. Okay, so I'm going to write it above it just to be clear. F of x equals 4 minus 3x minus x squared. Whatever is in here, it doesn't matter. Triangle, 17, a quadrillion, a plus b plus c plus d plus e. It doesn't matter what's in here. It replaces any x that you see completely and totally. 4 minus 3. There's an x here, not anymore. It's x plus 2. Do not forget the parentheses. Minus x here, it is now x plus 2. So we're going to square that whole thing. There we go. And so this is going to become, if we expand and simplify, 4 minus 3x minus 6 minus, and don't forget the parentheses, x plus 2 squared is x squared plus 4x plus 4. Simplify a little more. Let's see, 4 minus 6 is negative 2, so we can take care of that outside the parens. Minus 3x minus x squared minus 4x minus 4. See what we can combine. Negative x squared minus 7x minus 6. Booyah! Done. One last thing. Let's take a look at this. The domain of a function. We need to consider what values of the variable make the function undefined. For example, if you have the square root of something, this domain is greater than or equal to 0 since the square root of x does not have any meaning for us just yet. When x is less than 0 or when x is negative. We don't know how to yet handle the square root of something like, say, negative 6. Okay, so we have the same issue here, right? But what we would do is there's two issues that we have to consider. First of all, we have a square root. So x minus 1 must be greater than or equal to 0, right? Because this has to be positive. So x must be greater than or equal to 1. Okay. Also, we can't have 0 in the denominator, right? So we have to figure out when the square root of x minus 1 is equal to 0. Well, that's going to occur when x minus 1 equals 0, and that's going to be x is equal to 1. So if you look at the two of these, we can't have x equal to 1, so this turns into the domain only being x greater than 1, because again, it cannot be equal to 1, otherwise the denominator will be 0. So in set notation, we would say the set of x such that x is greater than 1, where x is an element of the real numbers. All right. Pretty straightforward, I hope. Very simple, very easy. We'll check back in here with the Smashing Pumpkins. Their smash hit single, 1979 is the title. One of my faves. And with that, I am... Ooh!